Now let's talk about hot spares. The concept of hot sparing is to have a spare drive in your system that can be used to automatically replace failed drives. The need from such being that when you have a failed drive in a RAID set, the fault tolerance of that RAID set is reduced, and another drive failure could cause you to lose data. So in a RAID configuration that has a hot spare drive available, that hot spare drive can be instantly and automatically used by the RAID controller to rebuild the contents of the failed drive, speeding up the process of returning the RAID set to full fault tolerance. This is particularly useful if, for example, you have a drive failure on a RAID set over a weekend, and there's nobody on site to replace that failed drive and start the rebuild process. Rather than wait until Monday morning and increase the period of time that your RAID set is operating at reduced resiliency, if you've got a hot spare, your RAID controller can immediately start the rebuild process. And depending on the size of your drives and the speed at which you've configured your RAID controller to rebuild failed drives, the rebuild process may well be finished by the time you arrive in the office on Monday morning. Now, the first and most basic form of hot sparing is to have a dedicated physical hot spare drive. Let's look at a small storage array with 15 drives. These various drives can be configured into various RAID groups. Now let's add a hot spare drive. With traditional hot sparing, that drive won't be used until a failure occurs. And the major risk to this approach is that when the time comes to use that drive and power it up ready to start rebuilding data to it, it may not power up. Not too dissimilar to a car being left turned off for a long period of time. When you come to try and start the car, it may let you down and it may not start up. And for this reason, some RAID controllers and storage arrays keep hot spare drives constantly powered on and spinning. However, even in these configurations, the single drive to rebuild to can become a bottleneck in rebuild performance. With this in mind, many advanced storage arrays employ a more modern method of hot sparing that we often refer to as virtual hot sparing or distributed hot sparing. Virtual hot sparing doesn't dedicate a physical drive as a hot spare. Instead, it ring-fences the equivalent amount of capacity on every disk drive in the RAID set so that there's always enough free space in the RAID set to recover from a failed drive, effectively distributing the spare capacity. After all, a dedicated spare drive is nothing more than an amount of capacity held in reserve that we use in the event of a drive failure. It makes no difference whether that reserved capacity is on a dedicated drive that sits there unused until a drive fails, or whether it's reserved capacity distributed over multiple drives that are constantly in use. Let's look at a quick few pictures to explain this concept of virtual hot sparing. First up, we've got a 5-drive RAID set, each drive being 400 gig in size. If this was a traditional hot sparing configuration, we'd take one of those drives and dedicate it as a hot spare. Instead though, we'll reserve 80 gigabytes of space on each of the 5 drives. 80 gigabytes multiplied by 5 is 400, so 400 gigabytes, meaning we'll lose the same amount of usable space that we would if we had dedicated one of the drives as a hot spare. This leaves us with 320 gigabytes of space per drive. Again, 320 multiplied by 5 is 1600, so we get the same usable capacity that we would if we dedicated a physical drive as a hot spare. But this time, we get the added benefit that when the array is working with all 5 drives, we get the performance, that is the IOPS and megabytes a second throughput of all 5 drives instead of just 4 of them. So we're putting all 5 drives to work instead of letting one of them sit around all day idling. Also, when we come to rebuild, all drives participate evenly in the rebuild process, rather than a dedicated hot spare being hammered harder than all of the other drives. So there are performance advantages to this approach, and as we can see, when a drive fails, the capacity previously reserved for hot sparing gets used, and there's no longer space reserved to recover from another failed drive. That is, at least not until the failed drive is replaced, and the RAID set rebalances itself back to normal operating state with distributed sparing. A quick point on rebuild prioritization before we move on to another topic. Most RAID controllers and storage arrays allow you to configure the priority at which data is reconstructed upon a drive failure. and you might naturally think that you would want to rebuild as fast as possible so that you reduce your window of risk, where a second drive failure would make you lose data. And that's a good train of thought to have. However, the faster the array rebuilds itself, the higher the impact this rebuild operation will have on the overall performance of the RAID set. Slower rebuilds allow the rebuild to work as more of a background task and have less impact on the RAID set's ability to service user I/O, whereas faster rebuilds increase the likelihood that users and applications will notice a performance hit. Now, let's address the question of whether we should go with hardware RAID or software RAID.